Alright, thanks for watching, and today I will tell you how to calculate a triple integral. So here, let's calculate the triple integral of the function z, where e is this very weird figure that we'll be able to draw. So it's a solid in the first octant under this plane 4x plus 2y plus z equals 4. So let's first draw a picture to see what's going on, and then I will also tell you what a triple integral is. So again, we're dealing with something in the xyz plane. So let's just draw that. xyz. And the question is, how can we draw 4x plus 2y plus z equals 4? Usually, by the way, the region is just some functions that you know, like cylinders or cones or spheres. This one, either it could be like, oh, let's just draw a plane with a certain normal vector, but you'll see it becomes very annoying to do so, and it doesn't give you any insight into what that is. Well, the good news is, because it's in the first octant, one thing that would help you simplify the process is just finding the z, y, and x intercepts. In other words, let's see where this weird object cuts the z-axis, the x-axis, and the y-axis. So let's do this. Let's draw the intercepts. So, for the z-intercept, what you do, you set x and y is 0. Because in order to figure out where your solid cuts the z-axis, at this point, both the x-coordinates and the y-coordinates are 0. And what you get is, well, 4 times 0 plus 2 times 0 plus z equals 4, which tells you z equals 4. So in other words, your solid cuts the z-axis at the point 4. And then let's continue. Let's find the y-intercept. What this means, you set the other variables to 0. So x is 0 and z is 0. So 4 times 0 plus 2y plus 0 equals 4. So 2y equals 4, and therefore y equals 2. So it cuts the y-axis in the point 2. Last but not least, let's do the x-intercept, which means you set y and z equals 0, and ultimately you get 4x equals 4, so x equals 1. Alright, very good. And now the question is, what is this thing 4x plus 2y plus z? Well, it's a plane that contains all those points. And in particular, it should contain the line connecting those points. Like this. And now it gives you a better idea of what the solid E is. First octant means x, y, and z are positive. So we're really talking about the region here. And z in E is everything underneath. So what this is, again, that's a 4x plus 2y plus z equals 4. Well, what E is everything below this plane. So in fact, all it is just a tetrahedron. So E is just a tetrahedron under this plane. So if you want a slightly better picture, maybe not ideal, but this triangular region where one vertex is below, like behind at the point 0, 0, 0, and then the other vertices are at the points 1, 2, and 4. So this is E, and the question is now, what is a triple integral? So you have to understand with double integrals, they measure the volume underneath a function. Here what it is, a triple integral is not a volume. So not a three-dimensional thing. What it is, it's what's called a hypervolume or a four-dimensional volume. The way to picture this is as follows. E is a three-dimensional object, but just think of it as being trapped on the whiteboard. The way I draw this is actually 2D because you have two directions going up and going to the right. Now imagine the function z, which lies kinda in this fourth dimension. So this fourth dimension whose axis is like that, then what the triple integral calculates is actually the volume behind my hand and above this solid E, which again is trapped in the whiteboard. So again, the volume behind between my hand, which is Z, and the whiteboard itself. I know it's a little bit tricky to visualize. Luckily, there's another interpretation. If you think of Z as being the density of the solid E, then in other words, if E has a property that it gets heavier, the higher up you go, then the triple integral calculates the mass of this solid E. And in fact, I have another video, fun video, where you can calculate the mass of the sun in that way. So highly recommend you to watch it. But this is not why we're here today. We're here to figure out how to calculate this triple integral. We have done the first step, which is to draw a picture. And now we need to figure out where x, y, and z are. So, first of all, you need to find an inequality for z, which is not super hard to do. So in general, it's much harder. Notice z is between two things. On one hand, the smaller function, so it's always z in this case, between small and big. Now, the small function, if you think about it, is just the xy plane. In other words, z equals 0. And that makes sense because in this case, z is positive. So z is greater or equal to 0. And then you need to figure out the bigger function. Well, the bigger function is just this plane. So this is the big function. And all you need to do is rewrite this in terms of z. But notice this is the same thing as saying z equals 4 minus 4x minus 2y. And in fact, that's how you get the first inequality. 4 minus 4x minus 2y. Okay, very good. And by the way, very normal, right? Z is usually trapped between two things that are just functions of x and y. Now, we found z, we need to figure out where x and y are. And for this, if you want kind of like double integrals, you need to look at the shadow underneath the function, which here is d. In other words, look at the base of your solid E, because that will help us to find inequalities for x and y. And the cool thing is there are two ways of doing this in this case. Let me tell you maybe the easier way. Notice the intercept here is 1, the x-intercept, and the y-intercept is 2. So first find the, find the equation of this line, which I believe what this is, let me just look up. Okay, it starts at 2. So y equals 2. And then the slope is minus 2. Because that's how we can get down to 0 in just 1 second. That's one thing. Or, if you're curious, is an even cooler way of doing this. Because this line here is just this thing here. And well, how can you figure that out? Well, it's precisely what happens when the plane intersects this other plane z equals 0. So just plug in z equals 0 here and see what happens. So 0 is 4 minus 4x minus 2y, which gives you 2y is 4 minus 4x, and therefore y is 2 minus 2x. How cool is that? You can just get the same line, but just using a little bit of 3D geometry. And then the question is, what is d? Well, it's just the stuff in between. And then using that, you also have, again, to find inequalities for y, and then an inequality for x. So let's do it for y. And unfortunately, we have to erase that picture. If you really want to look at it, you can just pause the video. And so what we get, just like for z, y is between the small function and the big function. Well, notice here the big function is just a diagonal line. So y is less than 2 minus 2x. And the small function, well, it's just the x-axis, which is just y equals 0. So y is trapped between 0 and 2 minus 2x. And last but not least, this gets a bit messy, but what is x? Well, x is just ranges between the leftmost point and the rightmost point. And then right, which in this case you need to have constants. So here x is between 0 and 1. And again, which is very typical of a triple integral, z is trapped between generally x and y is trapped between stuff with x, and then x is just trapped between constants. If you just do it in the z direction. And now we're ready to integrate. So I call this the Payam method because it's picture, inequalities, and math. So as an integrate, so what did we have? We had the triple integral of the function z, dx, dy, dz. And now, well, the function didn't change. We still have z, but now just plug in all the inequalities. Z was between 0 and 4 minus 4x minus 2y dz. So the order is very important. You start with z, and then you do y. Y is between 0 and 2 minus 2x. And then you do x, which is, in this case, between 0 and 1. And then you evaluate this. It looks like a nightmare, but I promise you it's not so bad. And by the way, the nice thing is now we completely describe the region in terms of inequalities, so the rest is just doing just a bunch of integrals. So it's triple integral, as in let's do 3 integrals. Very good. What is an antiderivative of z with respect to z? That's z squared over 2. So it's the integral from 0 to 1, integral from 0 to 2 minus 2x. All right, and then z squared over 2 from z equals 0 to z equals 4 minus 4x minus 2y, and then dy dx. this becomes, it's an integral from 0 to 1, integral from 0 to 2 minus 2x of 4 minus 4x minus 2y squared over 2. And then minus 0 squared over 2, so that doesn't matter. dy and dx. Maybe let me make this more apparent, so apparent or something. So it's this minus 2y. Okay, and let's figure out how to do this. And again, I'm not simplifying because there will be a nice simplification here. So it's the integral from 0 to 1 of, so when y equals 0 to y equals 2 minus 2x of dx. So we still have the 1/2. Okay, now to do this, an antiderivative of square is cubed. So 4 minus 4x minus 2y cubed over 3. Except, if you differentiate this with respect to y, you have an extra factor of minus 2. So you have to divide by minus 2 to make this work. And then what you get is minus 1/2 times 1/2 times 3, which I believe gives you minus 1/12 of the integral, or I guess, yeah, the integral from 0 to 1 of, you'll see there's a nice thing going on. So, let's see. 4 minus 4x minus 2 times. Plug in y now, 2 minus 2x. 2 minus 2x cubed. And then minus this, so 4 minus 4x cubed dx. And again, minus 2 times 0, so that's why 4 minus 4x. Notice what's happening here. We have 4 minus 4x minus 4 plus 4x, which just cancels out. So this thing actually disappears and becomes 0. And then minus minus is plus. So it's 1/12 times the integral from 0 to 1 of 4 minus 4x cubed dx. And then if you want to simplify, let's use a u substitution. So u equals 4 minus 4x. du is minus 4 dx. So dx, it's minus 1/4 du. And also u of 0 equals 4. U of 1 equals 0. And then what we get is 1/12 integral from 4 to 0 of, I think, u cubed, and then dx, which is minus 1/4 du. And then minus, you see the minus simplifies with this wrong order. And then 1/4 times 1/12, that becomes 1/48. So 1/48 integral from 0 to 4 of u cubed du. And that becomes 1/48 times u to the 4th over 4 from 0 to 4. So at 0 it's 0, and then let's see. Let's write it in this way. 48, it's actually a 4 times 12, so 4 times 4 times 3. And then what do we get? U to the 4th, which is 4 to the 4. So 4 times 4 times 4 times 4 divided by 4. And then the nice thing is, and this is why I wrote it in this way, the 3 4s cancel out, and we get 4/3, which which I really hope is the answer. Let's see. Oh well, I mean, I didn't even prepare this with the answer, so hopefully it's 4/3. If not, you can correct me in the comments. All right, and again, what is this saying? It says sort of, if you have the tetrahedron trapped in the whiteboard, and you have the function z floating around here, the hypervolume between your function z and the whiteboard is 4/3. Or again, if you have the tetrahedron with density z, the total mass becomes 4/3. And again, by the way, it's positive because you see z is positive in our problem, so that's what it becomes. All right, I hope you like this intro to triple integrals. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.